in this next section, I'm going to show you how to use technology to find a line of best fit. Now, in this example, we are going to look at some values. It's going to be the X values are the duration that Old Faithful gushes, and the Y values are the amount of time in between gushes. So you can see that I have entered already this data into the computer. So what I'm saying here is that if Old Faithful gushes for 2 minutes, then we see that it was 60 minutes before the next eruption. And I'm using a website called Alcula, and it has a linear regression calculator. So I just enter in all of my data points here, and then I'm going to click on Submit Data. Okay, so when I submit my data, it tells me all of my stuff that I need to know, and most importantly here, it tells me that my linear equation is y equals 35.106, etc., plus 11.99 blah 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 times x. So here is my linear equation, okay? And it also gives me a graph. So these x's are my data points, and this line right here is the line that the computer has calculated. All right, so back to looking at this slope and intercept, right? So I want to interpret these a little bit for you. It's always very important that when you're doing a linear regression that you provide some sort of interpretation. So this 11.99, our slope, that's almost 12. So let's just think about it as 12 for a minute. Our slope is 12. So that tells us that for every minute that the Old Faithful gushes, we get 12 minutes of increased time between gushes. And our slope, our y-intercept here is about 35. And that tells us that if we had a duration of 0 minutes, then our next geyser gush would happen in 35 minutes, or approximately 35 minutes. Now, this website also gives us a chance to calculate the correlation coefficient. If we scroll down here and click on correlation coefficient, it will tell us our correlation coefficient is about 0.9787. So this tells us that we have a very strong positive linear relationship between the duration of Old Faithful's gush and the amount of time between gushes. So now that you know how to use technology to find a line of best fit, we have to be careful not to confuse correlation with causation. I see that's a little bit blurry. I don't know how to fix it so that it's not so blurry, but I'm going to try. Just give me 1 second. Okay, that's better. So when a change in one variable causes a change in another variable, it is called causation. However, you have to be very, very careful because correlation does not imply causation. And there are a number of funny examples about this on the internet that you can look up, but we're going to look at a couple of fairly benign examples here. So in our next example, we're going to tell whether a correlation is likely in the situation given, and if so, we're going to tell whether there is a causal relationship. All right, so for part A, the time spent exercising and the number of calories burned. So there is probably a correlation between exercising and number of calories, and it is also causal, right? The more you exercise, the more calories you'll burn. Okay, but let's look at our next example, which is the number of banks and the population of a city. Now, we can definitely see that there should be a correlation between the number of banks and the population of a city, but it should not be causal. In other words, increasing the number of banks would not cause an increase in the population. Okay, so let's look back at our learning targets for this lesson. Okay, so I can use residuals to determine how well lines of fit model data. So please don't forget that you're going to look for the randomness. If the residual graph is random, the line is a good fit, and if it's not, the line is not a good fit. Secondly, I can use technology to find lines of best fit. So for you right now in Math 1, you find a linear regression calculator. You can either download one off of your phone or find one on the internet. Plug in your data points, and it will tell you your slope and your y-intercept for your line. And lastly, I can distinguish between the correlation and causation. So the most important lesson here to learn is that correlation does not necessarily mean causation. And we have to ask ourselves if a correlation, if changing one of the variables will cause a change in the other variable.